Good evening, everyone. It is my privilege to welcome you all to the distinguished IEEE Transportation Society Tech Talk. We are gathered here today to explore the latest advancement, innovations, and insights in the field of transportation. This event provides a unique platform for experts, researchers, and enthusiasts to come together and discuss the future of transportation technologies. As we embark on this intellectual journey, I want to express my gratitude to our esteemed speakers and presenters who have generously shared their knowledge and expertise with us. Their contributions will undoubtedly shed light on the evolving landscape of transportation. Let us make most of this opportunity to learn, collaborate, and exchange ideas. I encourage you to actively participate, ask questions, and engage in meaningful discussions. Together, we can drive the future of transportation towards sustainability, efficiency, and safety. Once again, welcome to the IEEE Transportation Society TikTok. May this event be a source of inspiration and knowledge for all of us. Thank you.
Okay, let's start the session. Today's topic is Lidar on a chip puts the self-driving car on the fast lane. Before going to the session, we talk about the Elon Musk. We all know about the Elon Musk who invented the self-driving Tesla car. From the invention, he didn't use the Lidar chip. Lidar is a light detection and ranking system which is used on a various self-driving car, and but he didn't use it because of his expensive cost and a lot of components integrated with it, but he uses a lidar on a chip in his Tesla car. Let's move to the session. What do you mean by lidar? Lidar is acronyms for light detection and tracking. In this lidar, laser light is sensed from a source transmitter and then are reflected from an object in the scene. The reflected light is detected by the receiver. From this, we can detect the range of the target object. In this, they uses a light of light systems also. Most of the developing autonomous vehicle companies are also stuck with the lidar system because of its cost and efficiency, because of the high cost. So they have such problems. This author would solve the problems by making the lidar chips on a small chip integrated with many sensors and transistors and waveguide and so on, makes the autonomous vehicles with an affordable price. The lidars makes a 3D map around the vehicle environment, which constructs a more fidelity than can be done with the cameras, and which makes the autonomous vehicle navigate through the road easier. Then the lidars can be used in various fields such as autonomous vehicle and pollution detection, agriculture and forest. In autonomous vehicle, the lidar system can be used for navigating the vehicle in a road. In pollution detection, how much the pollutant particles are present in air, and this will help the amount of pollutions that will occur in a city. The organization will take care of the pollution. In agriculture, the leaders makes the wide range of 3D view of the crop field, which will ensures the crop sunlight exposure, and thus makes the farmers to reduce the labor costs and watering the plants. In forest, water the plants in these forest area, and how the population of the animals will also be detected using the lidar system. Then the at the starting of the session, I told that Elon Musk introduced the Tesla, but without the intervention of the Lidar because of his high cost. In Elon Musk tweeted 2021, he tweeted as any expensive items or sensors which will not included in my car, that is a self-driving car, which will increases the cost. So he uses the lidar on a chips concepts. The author come across to overcome these problems by a small chips with this phased array lidars that slash the cost and simplifies this integration that makes the many automobile industries to achieve their goals. So, from the radars, the lidar is derived. That is the truth that the author said. Most of the new cars are equipped with more lidar sensors. The sensors are solid state that are manufactured less than the 100 US dollars. Many equipped car with braking facilities or any driverless assistance functions. But wasn't earlier, autonomous vehicles were launched due to mechanically steered radars that are a high cost. So we have a continuously waved emission and automotive radars for electrically steered radars. Radars is now undergoing in the same evolution. This Lidars have come to the vehicles entered by DARPA Grand Challenge. From this, the LiDAR sensor are introduced in the vehicles for the autonomous purpose, for the driverless purpose. With this cost efficient and LiDARs can be avoided in this autonomous vehicle because it have a more sensor integrated with it and have a high cost. The first generation of the radars, only so far, they have a spinning and scanning the mirror. What are the objects near the vehicles? How far the target is there? And is there any pedestrian nearby? Is there any gauge given by the pedestrians also detected by the radar? For spinning and scanning, the radar's cost will have increased. So the automobile industries or doesn't reach the goals by with this high cost. The companies the companies chosen to solve the lidar sensor, replacing it on a chip, which is integrated with a photonic integrated circuit, which is only made up of a ordinary silicon. The other are also doing with the lidar like a chip that have no moving parts, that have generator or emits or receive no lights with an external hardware that only have a tiny size that makes the lidar works. In this the frequency modulators continuous waves radars, they also have high advantages like if one wave is transmitted, there is an interruption of the another wave that may affect the wavelength or frequency of the another wave, that may causes the interruptions. From this we have calculated the distance of the object. One wave is transmitted and another wave is interrupted. The difference of the frequency or will also gives the distance of the target object. This will also gives an extra radar systems. If the reflected signals took a long time to make the round chip, the difference frequency will be large, so the target of the object will be also large. If the reflected signals took short time to bounce back, the difference in frequency will be small. So the distance of the target object will also be small or nearby around it. So the difference of the frequency between the outgoing and reflected signals provides some measures how far away the target is. And this is a major role played in autonomous vehicle to detect any cars nearby the autonomous vehicle or in front of it, to avoid the clash or accidents for vehicles. While they are have more complexities on a TOF based systems of time of flight. light systems. The FMCW system are more sensitive than the TOF system for different interruption of frequency modulators waves. And then shall we move to next slide. This is the author's Lidars. It consists of a two parts, that is one is silicon photo chip and a semiconductor photo chips that will controls all the electronic connections between the two chips. Higher magnification micrograph is also in the tinny copper bumps. The tinny copper bumps also make the electronic connection between these two chips, that is the silicon photo chips and the semiconductor chips. The automobile lidars is now a similar approach. As a FMCW, that's a frequency modulated continuous waves lidars like the wavelength and the transmitted light, then combining and backscattered light with the local oscillator. We have calculated the target distance of the target distance by ensuring the safety of the vehicle or a human in the road. This capacity is used for quickly identifying uh, how long velocity of the target objects, like how the target object is, the speed of the target objects, or how far and how much the time to take the target object to reach, and the pedestrian gestures also achieved by this FMCW. For this purpose, the additional dimension to the data FMCW system are also sometimes called as a 4D LiDAR systems. If As you might imagine that FMCW systems are very different from the laser source of that FTOF system. The FMCW LiDAR systems continuously emit the light and receive the light which have low peak power. So to avoid this, smaller chips based LiDARs are want to introduce steering light with a phased array. This is the next topic. The photonics integrated circuit was designed and fabricated with 300 millimeter diameter silicon wafers. Just it have a more integrated circuit for the chip. We makes the lidar system. Then the automobile industry combines on-chip with many optical components like lasers, optical amplifiers, waveguides and splitters, modulators, photodetector, and optical phased arrays also. Optical phased arrays is nothing but electrically steered radars are also like the phased arrays. Yeah, all the radars transmit and receives light. The transmission and the reception of light, we detect the range of the target object. From this, the radar system is also achieved. In a in the system, the discrete optical components are used. The discrete optical components must be aligned in a proper manner. If the alignment is not in a appropriate manner, the leaders can fail to work in a proper way. This wave, the waveguide carrying the light are also to fail, and the time and cost will also reduce its cost. Initially, the LiDAR system scanned either by spinning or rotating the cameras or introducing itself by scanning the mirror while exposure to the sunlight, etc. This will more the expensive cost and unreliable. Some radars are also point in their antennas mechanically that are used in the airports and marinas are in that I have shown in the picture. First one is used in the marinas. The radars are used to detect the ships from the coastal region, and the second one is mechanically steered antennas that are used in the airports. For this array, in the first pictures, this is a chips in the top surface is only used for receiving and transmitting the light to calculate the range of the target. In the ARM chip, the phase shifters and emitters are individually controlled, and then the type optical beams, ones that are just several millimeter wide. They are a tiny chip, so the range of the chips is only in a millimeter range. The the wavelength of the leaders that operates of 1550 nanometer. The phase shifter must be placed just 1.5 micrometer apart to enable a 60-degree steering range. The second picture is the graphical representation how the in how far the target is far in the graphical representation. So now the optical waveguides or the optical components are integrated in a circuit, and how closely it will integrate and how it will work. It depends upon the speed of the light. Adjust with them. We can connect them spatially with the waveguide. For this, the author uses a flip chip technology. They have a 75 micrometer apart. All the copper bumps are placed in the 75 micrometer apart. The CMOS chip has thousands of solder coated copper bumps. Uh, Flip chip technology is nothing but all the electrically components are placed in a chip in a single chip, and half of the human hair width is the chip. Hmm. It contains only the silicon photonic chips, so it is permanently mated with the semiconductor electronic chips. It need a digital logic and matching set of a copper bump. In this picture, the author's futures Lidar work. This is the Lidar which is used for in future. The author are going to explore in future for a wide range and in a large direction, and how velocity is far, and is also they are doing in the work for the lidars in future. They are doing the work. So now, the prototype of the first full solid state beam in the automobile industry, it changed the world so far. The leaders, the leaders on a chip, the author introduced was used used in autonomous vehicle to make a change, great change. The author currently working on a long range versions and to be mounted at the front of the car for use at the highway speeds, and a short range versions with a wider field of view to provide a complete coverage around the path. The two sensor different optical phased arrays in their photonics ICs while sharing the same backend signal processing. The author achieved the work by integrating the silicon photonics on a on chip. They This gives an proper solution to replace the lidar system, and the automobile industries or achieve the goal without the cost efficient. In future, the authors are going to work with the lidar systems, long range versions, and also car how long the car speed is in the highway, and short range visions also. And then thank you. If anyone have any doubt, ask me. Is there any queries? Anybody have queries? Okay.
With a sense of profound gratitude and appreciation for the insightful and enlightening tech we have just experienced. It is an honor and privilege to deliver this vote of thanks on behalf of all of us who have gathered here. First and foremost, I would like to express our deepest gratitude to our esteemed speaker for gracing us with their knowledge and expertise. Their presentation was not just informative but also incredibly engaging and thought provoking. We are truly fortunate to have the opportunity to learn from their wealth of experience in the tech industry. I would also like extend our thanks to event organizers for organizing and hosting this Tech Talk. Your efforts in bringing together experts and enthusiasts in the field of technology are commendable, and its event like this or contribute to the growth and development of tech community. To our attentive audience, thank you for your active participation, insightful questions, and the enthusiasm you brought to this event. Your presence has made the Tech Talk a truly interactive and enriching experience. Last but not least, let's not forget the power of technology itself, which has allowed us to come together today, transcending geographical boundaries and enabling us to share the knowledge and ideas. Thank you all once again for your active participation, and here's to more enlightening tech talks in the future. Have a wonderful day ahead.
Thank you.